Ladies and gentlemen, so expect to see these types of questions on tomorrow's quiz. State the degree, the leading coefficient. You know what? This is too easy. I want to ask you more than that. So I want to ask you everything that you could tell me about this. So let's jump to number 2, for example. And first of all, could you tell me the degree yet? No, you can't. You can't even tell me the constant or the leading coefficient. You can't tell me anything because it's still not simplified. You need to simplify it first. So 2x times 4x squared, that becomes 8x to the third. 2x times 3, that's 6x. And then we have negative 1. Negative 1 times 4x squared, that becomes negative 4x squared. Then negative 1 times positive 3, that's negative 3. And of course, it's still not in standard form. You have to write it in correct order from largest to smallest, largest exponent down to smallest. So 8x to the third minus 4x squared plus 6x minus 3. So now, once you do that on tomorrow's quiz, you're going to be asked several questions. Like, what is the leading coefficient? And you're going to say, the leading coefficient is what? 8. If I say, what is the degree of this function? What are you going to say? 3. Now, I might as well ask you this. Since you know the degree is 3, I could also ask you to write the end behavior of this graph that you don't even see the graph of, right? But you know it's a cubic function. If I asked you for the end behavior of this thing, if it were a graph, you would say, as x approaches, let's think about to the left, that's negative infinity. What do we know about cubic functions? What's the end behavior of the simplest type of cubic function? If you forgot, the simplest type of cubic function looks something like this, right? So this one is a cubic function. It's going to have the same end behavior as this guy. So as x approaches negative infinity, where's y approaching? Where's f of x approaching? That's right. You're going to say f of x approaches negative infinity. If I ask you, or then you're going to also say, and when x approaches positive infinity, f of x approaches what? Positive infinity. I only hear a couple of you guys answering. I hope you guys know this stuff already. Watch the videos on Edmodo. It'll get you better prepared for the end behavior. But anyways, that's another thing I could ask. Besides the leading coefficient and the degree, I could ask for the end behavior. I could even ask you to classify it with the first and last name. You guys remember that stuff? Yeah. So if I wanted to classify this guy, what would it be? Cubic polynomial, right? Cubic because the degree is 3. Polynomial because there's many terms. If it's 4 or more terms, 1, 2, 3, 4, it's polynomial. So cubic polynomial is the first and last name of this guy. Now let's say, let's do the same thing for this one. What degree is it? What's the degree? 1. The degree is 1. Okay, that's one answer. What's the leading coefficient? 1. That's another answer. Classify it, first and last name. Linear binomial. All right, linear binomial. So all these extra questions I'm going to give you, it's not just what they ask right here on your worksheet. State the degree and the leading coefficient. That's too easy. The degree is 1. The leading coefficient is 1 on number 1. So I'm going to ask you more questions like classify it, first and last name. Maybe I'll ask you about end behavior. I will ask you end behavior for sure, but maybe not on these. I don't know. So let's move on to this next part of the homework. Right here is the notation for you to use the p function and to plug in negative 1. And this is another question where it says use the p function and plug in positive 2. So it's actually asking you to do 2 problems, 2 questions. So p of negative 1 is simply the notation stating that you're going to plug in negative 1 in place of x. So here's my 4 minus 3x. Whenever you're going to plug in something, always rewrite the original function but put parentheses instead of your variable. And now you can plug in a negative 1 right there. And of course, do the math that you could do. What is negative 3 times negative 1? That's positive 3. So 4 plus 3 equals 7. So that's the first answer. P of negative 1 equals 7. Now you're going to go back and do a totally separate problem. P of 2. Okay, so let's actually plug in 2 into this function. So you have 4 minus 3 times parentheses. Like I said, always use parentheses, and then simply plug in what they ask you to plug in. So this is really going to be 4, not after, before. No, I'm just kidding. Okay, 4 minus 6. And 4 minus 6 is what? 4 minus 6 is what? Negative 2. So there's your second answer. So you actually get 2 answers because they're asking you to do 2 separate things, 2 separate problems. Would you guys like to see any up? Maybe number 9 or number 11? Or should we move on? Move on. Okay, so those 7, 9, 11, those are all easy because they're just asking you to plug in numbers. Now 13, 15, 17, those are more fun because you actually have to do operations and they ask you to plug in not numbers but actual variables. 13's cake. It's like an easy question. So it's this simple. Are we using the P function or the R function? P, obviously, because there's a P right there, right? Now, if it said P of 5, what would I do? I would plug in 5 right into my P function. But it's not P of 5. It's not P of 4. It's the actual letter. So they want you to take your A and plug it in for X. So maybe the less confusing thing to do is once you know that you're using P, I would rewrite the P function. What is the P function? It's 4x, but instead of x, I want to put parentheses, minus 3. That's always a great idea to do, because even if it said P of 5, you still have to do this and plug in a 5. But right here you have P of A, so what are we going to plug in instead of 5? A. And then you do any math possible. What is A squared? A squared is A squared. So 4A squared minus 3, that's it. You're done. Number 15 is a little bit more interesting. You have to know what you're reading here. 3 times R of A. So, obviously, which one are we using? R or P? Which function? The R function, right? So, whenever you're going to use a function, rewrite the function exactly the way it is, but use parentheses so you could have the spot to plug it in. So, I'm really going to rewrite 1 plus 3x, put parentheses. But what do they want us to plug in place of x? They want us to plug in A into the R. So I want to put an A right here. Now, I'm not even worried about, I'm only worried about R of A right now. Later on, I'll worry about this times 3 that's in the front, okay? So let me just worry about R of A right now. So let's do the math possible. 1 plus 3 times A. That's not 4A because you have to multiply first. So that's really going to be 1 plus 3A. Yay? Okay, now you're going to take this outside 3 value, put parentheses around what you got, and multiply everything by 3. So your final answer for number 15 is 3 plus 9A, or maybe 9A plus 3 is even better. It's in standard form right there. So all of these, they're all pretty easy. You're just plugging in. Now this last part is a little bit more challenging. By the way, I also recommend you to go to one of the previous videos on Edmodo where we have multi-step problems with functions. You guys remember those? We did one in class. We recorded it. Please watch that one so you could be better prepared for that challenging question on tomorrow's quiz. Now on this one right here, it says describe the end behavior. As a matter of fact, I want you to describe everything possible. So like on number 20, what do you guys think? Is this an odd function or an even function? Even degree function, right? How do you know that? Because the end behavior is both down here, right? Even degree functions have both end behavior either up on top or on the bottom. And that's pretty easy to remember because how many arrows are pointing down? 2. So that means that it's even. There's 2 arrows. 2 is even. Now, if it were something like this, if it were the red one, how many arrows are pointing down? 1. That would be an odd degree function. It's that simple, guys. Odd and even degree functions. If both arrows are pointing up, then it's even. If only one arrow is pointing up, it's odd. Simple as that. Let me erase it, though. So what am I going to ask on the quiz tomorrow with regards to number 20? Well, I'm going to ask you to state if it's odd or even, and you guys just told me it was even. Even degree function. Not only that, how about this? And they don't ask this on this worksheet, but I'm going to ask you on tomorrow's quiz. Is the A value positive or negative? Negative. A is negative because it's opening down, right? If it were positive, it would be opening up. So you guys need to know that on tomorrow's quiz also. Okay? So on 20, in addition to if it's odd degree, yeah, I spelled degree right, degree. Let's just pretend that R is not there. Degree. Okay. So I'm also going to ask you, in addition to odd degree or even degree, and in addition to is A positive or negative, I'm also going to ask you to state your end behavior. So on this guy, you would say as x approaches negative infinity. Now, what does that mean? As x, here's your x-axis, approaches negative infinity, what does your f of x approach? Negative infinity. So you would say f of x approaches negative infinity. Does that make sense? As x approaches positive infinity, f of x approaches what? As x approaches positive infinity, f of x approaches what? Negative infinity. So I'm also going to ask you to do end behavior. Cool? Cool. So I've also posted a extra video to prepare you for tomorrow's quiz. So please make sure you watch both videos tonight, okay?